This is section 7.5, geometric sequences. Okay, so a geometric sequence is just basically a set of numbers that's going to follow a pattern. And how that pattern is developed is it comes from multiplying your previous term, or the term that comes before the current one you're working on, by a constant, and a constant is just some sort of number. And then we call whatever that number we're multiplying by the constant multiplier. Okay, so in this case here, for this example, we got 30, 60, I had 90 there, but that's a typo, get rid of that. So 30, 60, 120, 240, 480, 960. So what's happening there is your first term is 30, because that's the one that's listed out first. Your second term, 60, is coming from taking your first term times 2. Then to get this third term of 120, you take your previous term, the 60, times 2, get 120, and so on there. Okay, so first term is the 30, constant multiplier is 2, because that's what we're multiplying by each time. So one way to write geometric sequences is using the recursive formula. To be able to use the recursive formula, you need to have the previous term. We're also going to do explicit formula in a little bit, and that one's a little bit different. You don't have to have the previous term when we do explicit, but for recursive, you do need to have the previous term, or the term that comes before the one you're looking for. But the setup for that is where we use that big curly bracket there. Then you've got some letter here, sub 1, that represents the first term. And then whatever that's equal to would be whatever your first term number is. Then you've got G sub n, which stands for like the term that you're on. So like second term, third term, whatever, is equal to R is always going to be your constant multiplier. So what it's multiplying by each time. And then the G sub n minus 1 is your previous term, so the term that came before that. So like here, if we were going to write this example up here with the 30, 60, 120, and so on there in that recursive form, it would be like our curly bracket. Your G sub 1 would be like your first term, which would be the 30. Your G sub n for the terms following that would be 2 for the constant multiplier, times, and then just your previous term there. So G sub n minus 1. So then you just take those previous terms, plug them in. So like if I was trying to find the second term, I would take the term before that, which is 30, put that in there, times 2, and I would get 60. So that's one situation there. So let's look at an example that's kind of similar to that. So it says give the first 6 terms and the constant multiplier of the geometric sequence G, where G sub 1 is equal to 5, G sub n is equal to 4 times G sub n minus 1 for the previous term. For integers, n is greater than or equal to 2. So the n is greater than or equal to 2 is just saying this pattern is going, or this formula is going to work for all of the numbers past the first term, is all that's saying. So what we're going to do here is we're going to take and we're going to go, okay, well the first of our 6 terms has got to be 5, because that's in that first term position. And then each term after that is going to be the previous one multiplied by 4. There's an easy way to do this on the calculator where you don't have to keep repeating, typing this in over and over again. So what you're going to do is you're going to go to your calculator here. You're just going to type in whatever the number is for your first term. So in our case, 5. Hit enter, and it's just going to kick out a 5 because you didn't do anything. But now what that allows you to do is it allows you to multiply using the answer function. So if I just go times, and our constant multiplier here is 4. So if I do it times 4 and then hit enter, I get 20. But what's nice about this, instead of having to type this in again, if I just hit enter again, it will take my previous number there and multiply it by 4. And then if I do that again, it's going to take that 80 times 4, get me 320. So that's a quick way of doing that without, retyping it in each time to multiply it by the same number. So like our first term was 5. When we multiplied by the first 4, that gave us a second term of 20. Multiplied by 4 again, gave us 80. Took that number times 4 again, got 320. And then what do we got to have? 6 of these, so that's the first 4. Fifth one would be 1,280, and the sixth one would be 5,120. So that would give you your first 6 terms. And 5,120. And then it also asks there for what the constant multiplier is. So in our case, it's what we were multiplying by, so we know that that's 4. So those would be our first 6 terms, and then our constant multiplier would be 4. And if you want the steps that I said for the calculator, basically what I did is, let's draw a line here, I typed in 5, typed right, typed 5, then I hit enter, and then after I hit enter, the enter's the important thing, you want to hit times whatever your constant multiplier is. So like in our case it was 4, so I did times 4, and then hit enter, and then you just keep hitting enter as many times as you need to come up with all the terms in your list. Okay, so you just type in whatever your first term is, make sure you hit enter, otherwise it won't work. Then you just hit times 4 and then enter, and then enter, 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 enter as many times as you need. So that just kind of is a quick way to do that little process. Okay, next thing here is explicit formula. So this is a way to get the same answers for our geometric sequences, but instead of needing to know the previous term or the number that comes before it in the list, you can find any number in the list at any time without needing to know what the previous number is. This is very helpful when you have situations where it says like find the 50th term of something, because obviously typing, you know, whatever the thing is into the calculator and hitting enter 50 times would be a pain in the butt to do. So this explicit formula is an easier way of doing it where you don't have to hit the calculator button a bunch of times. So how this one works, so it's g sub n for whatever term we're looking for, is equal to g sub 1. So g sub 1 again is just the first term. R again stands for the constant multiplier, what we're multiplying by each time. And then this time we've got the power of n minus 1, so that would be n is our current term number, and then you always do 1 minus that to kind of go back like a term number. Okay, so like if I was setting this up for that first example we did with the 30 and then constant multiplier of 2, it would be like g sub n is equal to 30 for our first term. Our constant multiplier was 2, and then it would be the power of n minus 1, and again the n is just whatever term number you're looking for. So like if you were looking for the 50th term, you would just put a 50 in there. Okay, so let's try some with the explicit formula then. Okay, so our second example here wants us to write the first, 5th, 10th, 20th, and 25th terms of the sequence defined by a sub n is equal to 3, and then times negative 2 to the power of n minus 1. Okay, so for our first term here, it would be like a sub 1 if we were putting it into this form. And then this one, you don't really have to do this, but I'll show you anyways. So if I'm putting it into my formula there, so 3 times negative 2 to the power of, again, our n is whatever term we're looking for, so it's the first term. So 1 minus 1. What's going to end up happening here with this, it'll just be 3 times negative 2, and then 1 minus 1 is 0. We know when we take anything to the power of 0, it's always the same as 1. So it'd just be 3 times 1, which is just going to kick out a 3. We already knew that anyways, though, because we know that this in this position here after the equal and before the constant multiplier, that number's always the first term. So you don't have to do that out for the first term. You could just say that it's 3, but I wanted to show you where that came from anyways. Next one, they want us to do it for the 5th term. So I would do a line here so we know it's a separate one. So a sub 5 for the 5th term is equal to still 3 for that front number for our first term, parentheses negative 2, because that's our constant multiplier. The 5 is going to go in the spot of the n, so 5 minus 1. Then you just simplify that out, so it would be like 3 times negative 2, and then that would switch to 4. And then up to you, you can either type them separate in your calculator, like you could type negative 2 to the 4th and then times 3, or you could type it in all at once. I'm just going to go all at once because it should pick up order of operations. So if I go 3 parentheses negative 2 to the power of 4, that kicks me out of 48. So my a sub 5, or my fifth term, would be 48. We'll just do the same thing for the next one. So 10, so a sub 10 is equal to 3 times negative 2 to the power of our term there's 10. So 10 minus 1, which would be the same as 3 times negative 2. 10 minus 1 is 9 to the 9th. So a sub 10 for our 10th term. Again, I would just type that in. So I just go 3 parentheses negative 2 to the power of 9. And that gives me a negative 1,536. And I'll just kind of go up here to get these other ones. So a sub 20 is equal to 3 times negative 2 to the power of 20 minus 1. We know 20 minus 1 is 19. So 3 times negative 2 to the power of 19. That'll give us our 20th term. So I just do that. 3 parentheses negative 2 parentheses power of 19, which gives me a pretty big number there. So we got negative, I think it's negative 1,572,864. And that would be our a sub 20. And then the last one there, we got the 25th. So a sub 25 is equal to 3 parentheses negative 2 to the 25 minus 1. We know 25 minus 1 is 24. So 3 times negative 2 to the 24th. So a sub 25 for the 25th term. We'll type that in our calculator. 3 parentheses negative 2 to the power of 24. Which also gives us a really big number there. So this would be 50,331,648. And that would be the 25th term. So that way, with the explicit formula, is much easier than typing that formula into the calculator and then just hitting enter 25 times. That would take a long time, and then you might, lose count of how many times you do it, which would be kind of a pain. Okay, last one here. So we've got, suppose a ball is dropped from a height of 12 feet and bounces up to 90% of its previous height after each bounce. Let h sub n be the maximum height of the ball after the nth bounce. Okay, so I'm going to sketch a picture of this here. So if I've just got, I'm going to turn this into a little graph here. So I'm kind of like that. If originally I have this ball up top here, and it is at 12 foot high, and I, drop it or whatever, and I let it bounce. We know when we let a ball bounce, it's going to go down, and then it's going to come back up. But when it comes back up, it's probably not going as high as it originally had been dropped from. Here they tell us it's going up 90% of its original height. So, somewhere kind of maybe right in there. It's going to go back down, bounce again. Again, just get a little bit shorter for the bounce. And then it's just going to keep going there and get slightly shorter, all the way, until it hits the ground and kind of, just rolls off or something like that. So that's kind of the situation. What they want us to do for our kind of setup here is, like I said, it's a bounce of 90% of its previous height. And then it's after, it says, let h sub n be the max height of the ball after the nth bounce. So the bounces are when it's hitting the ground here. So this doesn't count as anything because that's when we dropped it. So this would be like the first bounce, second, third, fourth, fifth, sixth, and so on there. Until it, rolls on or whatever it's going to do. So then when they're talking about the height after that, it's the height, or like the max height, after that first bounce. So like this would be like h sub 1. And then that next one there would be like h sub 2, h sub 3, and so on there. Okay? So that's kind of what they're talking about. And then it says find an explicit formula for the h sub n. So what you're going to want to do here is figure out like your first term and your constant multiplier. The tricky thing here with the first term is a lot of times people think it's 12 for the first term, but it tells us here that our h sub n is coming after the bounce. So our first term is actually going to be whatever this height bounce is here. It's not going to be the 12, okay, because that was before it even bounced. So we're going to use this h sub 1, whatever that would be, as our first term. So what you would do to figure out that height is you just take your original 12 foot and you take 90% of that. So you would just take 12 times 0.9, which would be like 90%, or you could put 90 either way. And then multiply that out, which would be 12 times 0.9 is 10.8. So that would tell you after the first bounce, it's 10.8, and then it's basically going to be 90% of 10.8, then 90% of that number, 90% of that number, and it's just going to keep going there. So when you set this up for h sub n for your kind of generic formula here, your first term that you're using is that 10.8 because that was our first height after the bounce. So 10.8. And then each time it's going to go like down by 10%. So it's going to be 90% of that previous term. So you're just going to take that same 90% number and put that in there. So either 0.9 or 0.90 because it's 90% of whatever the previous thing is. And then it would be to the power of n minus 1. So that would kind of be like our generic formula that we could use. And then it says find the max height of the ball after the 6th bounce. So basically, we did it all those times out there. That was a 5th bounce. So like h sub 5 would be there. After the 6th bounce, it would be h sub 6. So when we do this, it's going to be h sub 6 for our height after our 6th bounce is equal to, and then we just take that formula there, so like 10.8 times 0.9 or 0.90 to the power of, and then our term is 6, so 6 minus 1. We know 6 minus 1 is 5, so it'd be the same as 10.8 times 0.90 or 0.9 to the power of 5. And then, like I said, I would just do that out on my calculator, so I'd do 10.8 and then in parentheses 0.9 to the power of 5, and that gives me a decimal number there. It's okay if we round that as long as we only round once. So then that would tell me that my h sub 6, or after the 6th bounce, would be, I'm going to switch this to approximately equal to 6 point, I'm going to go 377, and then that would be in feet. So about 6.3 or 6.4 feet after the 6th bounce. Okay, so that's it for notes. So you got that book page there for tomorrow. So 482, 2 to 19, skip number 7, and skip number 10.